Welcome to Candid Breakdown of 4 technical questions that tripped me up during a software engineering interview. In this video, I'll walk you through the actual questions, my answers, where I went wrong, and what I learned. If you're preparing for backend engineering interviews, these scenarios will look familiar. The company was a B2B SaaS firm in Midtown, with about 150 engineers building workflow automation for enterprise clients. My role was for a mid-level backend position, focusing on their API platform. The on-site interview consisted of 4 rounds, 2 coding, 1 system design, and 1 behavioral. The coding rounds were where the real challenges emerged, and that's what we'll focus on. Let's start with the structure of the interview. The process was rigorous, designed to test both technical depth and practical application. 2 coding rounds were followed by system design and behavioral interviews. The coding rounds were especially intense, with real-world scenarios and follow-up questions that probed deeper than surface-level knowledge. This approach revealed gaps in my understanding that I hadn't noticed before. The company's focus on workflow automation meant that their questions were highly relevant to production backend systems, not just textbook theory. First technical question was about designing a rate limiter for their public API. The interviewer described a scenario where a few large customers were hitting the API at volumes that degraded performance for everyone else. I was asked to design and implement a rate limiter. I talked about using a counter per API key in Redis, checking the count on each request, and returning a 429 error if the count exceeded the limit within a time window. I coded a fixed window counter, checking whether the current minutes count for that API key had exceeded the threshold. If yes, reject. If no, increment and allow. Interviewer then asked what happens at the boundary between 2 windows. If a client sends 90 requests in the last 10 seconds of minute 1 and 90 in the first 10 seconds of minute 2, with a limit of 100 per minute, my counter would allow all 180. This creates a burst that exceeds the intended rate limit. I hadn't considered this edge case. The interviewer explained that this is a common pitfall with fixed window counters, which can lead to cascading failures during traffic spikes. Recognizing and addressing these boundary issues is crucial for robust rate limiting. The better answer would have been to use a sliding window log or sliding window counter. The sliding window log keeps a sorted set of timestamps for each request per key and counts how many fall within the last 60 seconds on every new request. The sliding window counter is a lighter approximation that weights the previous window's count by the fraction of time elapsed in the current window. Both approaches solve the boundary burst problem, unlike the fixed window counter. Understanding these algorithms is essential for designing production-ready rate limiters. The interviewer wasn't upset that I didn't know the sliding window algorithm, but was concerned that I didn't identify the boundary problem on my own. In real systems, edge cases like this are the difference between a rate limiter that works and one that fails when you need it most. This experience taught me the importance of thinking beyond the basic implementation and considering how algorithms behave under real-world conditions, especially during traffic spikes. Second question shifted to database indexing under load. The interviewer described a Postgres table with about 50 million rows storing API request logs. The table had columns for API key, endpoint, timestamp, response code, and latency MS. The task was to run a query fetching all requests for a specific API key within a given time range, sorted by timestamp descending. I suggested creating an index on API key, thinking it would be sufficient for the query. Interviewer asked whether a single-column index was enough. With 50 million records and the top 10 customers generating 60% of the traffic, a single API key could have around 3 million rows. Fetching these rows with a single-column index and then sorting them by timestamp in memory is inefficient and can lead to performance bottlenecks. I realized this was a problem, but didn't know the specific fix at the time. The optimal solution is a composite index on API key, timestamp DESC. This allows the database to satisfy both the equality filter on API key and the ordering by timestamp in a single index scan, avoiding in-memory sorting. For queries with a time range filter, the composite index enables efficient range scans. This can reduce query times from 15 seconds to 200 milliseconds, making a huge difference in production environments. Understanding when and why to use composite indexes is key for backend engineers. Although I knew about composite indexes conceptually, I hadn't applied them in real scenarios with performance constraints. The gap was not in vocabulary, but in applied understanding. This experience highlighted the importance of hands-on practice and reasoning about performance under load, not just knowing the theory. For backend roles, practical experience with indexing strategies can be the difference between passing and failing an interview. The third question involved concurrency and race conditions. The scenario was two users simultaneously trying to book the last available seat in an event booking system. I was asked to write booking logic that prevents double booking. I wrote a function that checks if the seat count is greater than 0, decrements it, and creates a booking record, using a try-except block around the database operations. Interviewer asked what happens if both requests read the seat count as 1 at the same time, before either writes the decrement. This is a classic race condition. I recognized the issue and suggested using a lock, but was vague about the type and location. The interviewer pointed out that an in-process mutex wouldn't help in a distributed system with multiple application servers. I mentioned transactions but couldn't articulate the specific isolation level or locking strategy needed. The better answer involves database-level mechanisms. One approach is using select for update inside a serializable transaction, which acquires a row-level lock and prevents other transactions from reading the seat count until the first one commits or rolls back. Another is optimistic concurrency control with a version column, retrying updates if another transaction gets there first. A third option is a unique index constraint, letting the database enforce uniqueness. Understanding these strategies is crucial for handling concurrency in distributed systems. The interviewer was testing whether I understood that concurrency in a distributed system cannot be solved with an in-process lock. Describing at least one database-level mechanism is essential. My inability to articulate a confident solution revealed a real gap in my applied knowledge. This experience underscored the importance of understanding how distributed systems handle concurrency and why database-level strategies are necessary. The fourth question was about API design and backwards compatibility. The booking API currently returns a JSON response with booking ID, status, and seat number. The product team wanted to add support for booking multiple seats in a single request. I was asked how I would change the API to support this without breaking existing clients that expect the current response format. I suggested changing the response to return an array of bookings instead of a single object. The interviewer asked what would happen to existing mobile apps expecting a single object at the top level. I realized my answer would break every existing client. I backtracked and suggested adding a new endpoint, but was questioned about the long-term strategy of maintaining two endpoints for the same operation. I didn't have a clean answer. The better answer is versioning the API. You can use URL versioning, e.g., v1 bookings versus v2 bookings, header versioning, or a combination. The v1 endpoint continues to return the single object format, while v2 returns the new array format. Existing clients are unaffected, and new clients use v2. Over time, v1 can be deprecated with advance notice and a migration timeline. Another approach is to make the change backwards compatible by keeping the original fields and adding a new bookings array. Old clients ignore the new field, while new clients use the array. The interviewer was testing whether I understood that APIs are contracts with existing consumers, and that changing the shape of a response is a breaking change. While I understood this in theory, I hadn't handled it in practice. This experience highlighted the importance of designing APIs with backwards compatibility in mind, especially for products with deployed clients relying on specific response formats. None of these questions were obscure. Rate limiting, composite indexes, database concurrency, and API versioning are all standard topics for mid-level backend engineers. I had some familiarity with each, but my understanding stopped just before the depth the interviewer expected. The feedback was that my foundational knowledge was promising, but my applied understanding of production backend systems was not yet at the required level. This was fair and accurate. After the interview, I changed how I studied. Instead of covering more topics broadly, I picked the topics I had already seen in interviews and went one level deeper on each. For rate limiting, I implemented 3 different algorithms: fixed window, sliding window log, and token bucket, and learned the trade-offs between them. For database indexing, I read the Postgres documentation, ran explain analyze on queries, and watched the query plan change with composite indexes. For concurrency, I wrote small programs that simulated race conditions and tested different locking strategies against a real database. This hands-on approach was slower than covering new topics, but it meant that the next time an interviewer asked a follow-up question one level deeper, I actually had something to say. Practical experience is invaluable for back-end engineering interviews, where depth of understanding is often tested. This experience taught me that depth matters more than breadth in technical interviews. Interviewers often probe beyond surface-level answers, seeking applied understanding and practical reasoning. Covering topics broadly is useful, but going deeper on core concepts is what sets candidates apart. Focusing on depth ensures you're prepared for follow-up questions and real-world scenarios. Let's revisit rate-limiting algorithms. Fixed window counters are simple but prone to boundary burst issues. Sliding window logs and counters offer more accurate rate limiting by tracking requests within a moving time window. Token bucket algorithms provide flexibility for handling bursts. Understanding the trade-offs between these algorithms is crucial for designing scalable APIs. Postgres supports various index types, including single-column and composite indexes. Composite indexes are especially useful for queries with multiple filters and ordering requirements. Running explain analyze on queries helps visualize the impact of different indexes and optimize performance. Practical experience with indexing strategies is essential for backend engineers. Simulating race conditions in code helps understand how different locking strategies work. Testing select for update, optimistic concurrency control, and unique constraints against a real database reveals their strengths and weaknesses. This hands-on practice builds confidence and prepares you for interview scenarios involving distributed systems and concurrency. API versioning can be implemented through URL versioning, header versioning, or a combination. Maintaining backwards compatibility ensures existing clients are not broken by changes. Planning deprecation timelines and migration strategies is important for evolving APIs without disrupting users. Understanding these strategies is vital for backend engineers working on public APIs. Receiving constructive feedback from interviewers and recruiters is invaluable. It highlights areas for improvement and guides your study approach. In my case, the feedback was that my foundational knowledge was good, but my applied understanding needed work. Taking this feedback seriously and adjusting your preparation can make all the difference in future interviews. Preparing for technical interviews involves more than memorizing concepts. Practicing real-world scenarios, implementing algorithms, and reasoning about edge cases builds the depth needed to succeed. Resources like PracHub organize questions by company and include follow-ups that probe deeper than surface-level answers. Practicing with these tools helps bridge the gap between theory and application. Surface is where everyone starts, but depth is where offers are decided. Interviewers often ask follow-up questions that require deeper reasoning and practical experience. Focusing on depth ensures you're ready for these challenges and can demonstrate your ability to handle production scenarios. This mindset shift is key for landing high-paying back-end roles. As a woman in tech, sharing these experiences helps others prepare for similar challenges. Technical interviews can be daunting, but learning from mistakes and adjusting your approach builds resilience and confidence. Supporting each other and sharing actionable steps is crucial for helping more women land high-paying roles in software engineering. Backend engineering interviews test a range of skills, from rate limiting and indexing to concurrency and API design. Understanding the depth of these topics and practicing real-world scenarios is essential. Building foundational knowledge and applied understanding prepares you for the challenges of production systems and interview follow-ups. The company's focus on workflow automation for enterprise customers influence the interview question. Real-world scenarios involving high traffic, large datasets, and distributed systems are common in such environments. Preparing for these contexts ensures you're ready to tackle the challenges faced by modern backend teams. Working on an API platform involves designing robust rate limiters, optimizing database queries, handling concurrency, and maintaining backwards compatibility. Each of these challenges requires both theoretical knowledge and practical experience. Preparing for API platform roles means understanding how to build scalable, reliable, and user-friendly systems. The coding rounds were the most challenging part of the interview. Real-world scenarios, edge cases, and follow-up questions tested my ability to reason about production systems. Practicing coding questions with depth and understanding the underlying concepts is crucial for success in back-end engineering interviews. While the system design round wasn't the focus of this interview, understanding how rate limiting, indexing, concurrency, and API design fit into larger architectures is important. System design interviews often test your ability to reason about scalability, reliability, and maintainability. Practicing these skills prepares you for both coding and design rounds. Behavioral interviews assess your communication, teamwork, and problem-solving skills. Reflecting on technical challenges and learning from mistakes demonstrates growth and resilience. Sharing your learning process and how you adjusted your preparation can impress interviewers and show your commitment to improvement. Recognizing and addressing edge cases is a hallmark of strong backend engineers. Whether it's boundary bursts in rate limiting or race conditions in booking systems, thinking beyond the basic implementation is essential. Practicing edge case scenarios builds confidence and prepares you for real-world challenges. Every algorithm has trade-offs. Fixed window counters are simple but prone to bursts. Sliding window logs are accurate but require more storage. Token buckets handle bursts but may allow temporary spikes. Understanding these trade-offs helps you choose the right algorithm for your system's needs and explain your reasoning in interviews. Optimizing performance under load is critical for backend systems. Efficient indexing, query optimization, and concurrency control ensure your systems scale and remain reliable. Practicing these skills and understanding their impact on real-world performance prepares you for production challenges and interview scenarios. When evolving APIs or database schemas, planning migration strategies is essential. Ensuring backwards compatibility, communicating changes, and providing migration timelines helps users transition smoothly. Understanding migration best practices is important for backend engineers working on evolving products. Continuous improvement is key to success in software engineering. Learning from mistakes, seeking feedback, and adjusting your preparation ensures you're always growing. Embracing this mindset helps you tackle new challenges and advance your career in backend engineering. To prepare for backend interviews, focus on depth over breadth. Implement algorithms, run database queries, simulate concurrency, and practice API design scenarios. Use resources that include follow-up questions and edge cases. This approach builds the applied understanding needed to succeed in technical interviews. Approaching interviews with a mindset of learning and growth helps reduce anxiety and build confidence. Mistakes are opportunities to improve. Sharing your learning process and how you overcame challenges demonstrates resilience and adaptability, qualities valued by employers. In summary, technical interviews test both foundational knowledge and applied understanding. Rate limiting, indexing, concurrency, and API design are core topics for backend engineers. Practicing real-world scenarios, focusing on depth, and learning from feedback prepares you for success. Remember, the surface is where everyone starts, but depth is where offers are decided. Thank you for joining me on this journey through the 4 questions I got wrong during my software interview. I hope these insights help you prepare for your own interviews and build the depth needed to succeed. Stay tuned for more actionable tips and real-world scenarios in upcoming videos. Together, we can navigate the challenges of backend engineering interviews and land high-paying roles.